We're going to finish up here our adding and subtracting, and tomorrow we'll do a little bit of review, and Friday you will have a quiz over all of our rational operations, simplifying, excluded values, adding, subtracting, multiplying, and dividing with rationals. So just be prepared here as we're finishing up adding and subtracting. You will be having a review tomorrow, quiz on Friday. Alright, let's get into using factoring to help us find common denominators. This is where you have to have an advanced understanding of what a common denominator is and how you can put things together. We've been doing this with some simpler fractions. Now we're going to look at a problem like this. Hopefully, when you look at the right portion of our graph, when you look over here, hopefully you're looking at those numbers 3, 12, and 21 and recognizing that I can divide a 3 out of both of those. But you're also probably thinking, man, it'd be really nice if I could divide a 3x out of both of those, because that would mean I could do nothing to the right side. That's not the case. So I'm going to rewrite the bottom here as 3 times x squared plus 4x minus 7. Just factoring out the common factor of 3. In order to save space, I'm going to just erase the original, because we've replaced it with an equivalent value. By factoring, I can look at my two denominators now. I have 3 times x and 3 times x squared plus 4x minus 7. We want to keep our denominator as simple as possible, and we don't want to get in the habit of just always multiplying by the opposite denominator. When you look here, as we talk about the word common, recognize we have a 3 in common to both sides. So therefore, I would be doing extra work if I multiplied this right side by 3x on top and bottom. That would be extra work because I've already got the 3 there. In order to make the denominators the same, I need to multiply by what's not shared. We have this single x over here on the left side that we don't have on the right side. So on the right side, I'm going to multiply both the top and bottom by x. On the left side, I have the 3. What I don't have is the x squared plus 4x minus 7. So I'm going to multiply by x squared plus 4x minus 7 on both the top and bottom. Which leads to, if I distribute 2 through the top, 2x squared plus 8x minus 14, plus, when I distribute the x times the 2x minus 4, 2x squared minus 4x. Now you notice I went ahead and wrote this as one fraction. We did a bunch of these examples on Monday, and hopefully you recognized once I've done the work to make a common denominator, it becomes one single fraction. Now my denominator is going to be a little bit tricky for some of you, because I have basically 4 different factors right now that I'm going to look at. I've got this 3, the x, this 3, and this x squared plus 4x minus 7. And of those 4 factors, the 3 is shared. So therefore, I'm going to have a 3 in my common denominator, and I did not multiply either side by 3 because the 3 was already there. In order to make everything be represented in the denominator, the x will be there, as will the x squared plus 4x minus 7. So there's my common denominator. The 3 was shared, the x wasn't. So that's where this x is coming in. The x squared plus 4x minus 7 was not shared. That's where it came in. So now I have a common denominator. I put my tops together, 4x squared, 8x minus 4x is 4x, minus 14 is by itself. My denominator, we said we can always leave in factored form. There's the solution to that problem. We're getting into pretty advanced fraction work here as we're looking at shared factors. Let's look at another example. At this point in Algebra 2, you've seen so many factoring problems that I really hope you look at those bottoms, and those are becoming almost automatic, that we know we can rewrite those right away. 3 and 4 add to 7 and multiply to 12. So I rewrite my denominator in factored form. X squared minus 5x minus 24, negative 8, and positive 3 will multiply to negative 24 and add to negative 5. So when you look at your denominators, again, I'm looking for x plus 3, x plus 4, the factors on that bottom, x minus 8, x plus 3 on this bottom. Hopefully, again, recognition, x plus 3 is shared. So there's really only 3 factors on bottom. While there are 4 written there, the x plus 3 is a common factor already to both bottoms. So therefore, the common denominator to this problem is going to be x plus 3, x plus 4, x minus 8. Because those are the 3 parts that show up in the bottom. When I look at my first problem, in order to make this x plus 3, x plus 4 look like the denominator in my answer, I need the x minus 8. And whatever I do to the bottom, I've got to do to the top. So that's 4x squared minus 32x. And now, this is a subtraction problem, so we said we always treat the tops like they're in parentheses, so we make sure we combine our like terms correctly. In our second fraction, I've already got the x minus 8 and the x plus 3. The x plus 4 is missing. So I multiply by x plus 4. When I multiply 5 times x plus 4, it's 5x plus 20. Which gets us to our final answer, once all like terms are combined, of 4x squared minus 37x minus 20 over x plus 3 times x plus 4 times x minus 8. You're going to be challenged in your ability to use common denominators today. You're going to have some problems that look just like what they did on Monday. Some are going to require you to factor first and recognize that you have a common factor that you don't need to use when you multiply both sides. Good luck, and we'll discuss questions you have tomorrow. Remember, Quiz Friday.